Let's talk about rational equations. So we've solved linear equations, we solved linear equations with fractions, we want to solve rational equations. And the thing that makes a rational equation different from a linear equation is that a variable appears in at least one of the denominators. So if you see an equation where there's a variable in the denominator, you should think, use the process for solving a rational equation. The nice part about this process is we sort of take the equation and turn it into a linear equation that we already know. So how do we solve a rational equation? So we want to make the variables come to the numerator. So we basically want to eliminate the denominator. We do that by following these steps. Step number 1 is to find all the values which make the denominator 0 and exclude them. Step number 2 is to find a common denominator. We'll call that CD for short. So we talked last time about finding common denominators, and basically one way to do that is to multiply all the denominators together. When we're doing rational equations, we might want to be a little bit more careful than that. For instance, we might want to do a little bit of factoring out the greatest common factor so that our denominators don't get really large with variables in them. Okay, so then just like we did with linear equations with fractions, we multiply every term by the common denominator. So remember, when you do this step, multiplying every term by the common denominator, all of the denominators should be eliminated, and you should end up with a linear equation. If you don't, then you maybe made a bad choice of what your common denominator should be, okay? So after step number 3, when you multiply every term by the common denominator, all the denominators should be gone. If not, try again. Okay, step number 4, solve the resulting equation. It should just be nice and linear. And step number 5, which is important in rational equations, is to check your solutions. Remember, the variable appears in the denominator. So if you do all the work and you solve your equation at the end, and you get a number that you excluded in step number 1, then we're going to say that the rational equation has no solution. So an important and a necessary step in solving rational equations is to do that check at the end to make sure that the solution that you got is actually a solution and is not one of your excluded values. So let's try it. First, we're going to identify the restrictions, that's step number 1, then solve the equation. Remember, we can check by just plugging back in. Okay, so here we see we have 3 denominators. We have an x, a 2x, and a 4x. Now, if I were to just multiply all those together, I would get 8x squared. But I don't need x squared because I only have x down there. So for my common denominator, I'm going to use 8x. I got the 8 because I did 2 times 4, and then I see the x's out there. I'm going to multiply every term, there are 4 terms in this equation, by 8x. Okay, so I cancel and simplify. Notice that in the first term, the x's cancel. In the second term, nothing cancels. In the third term, the x's cancel, and when I do 8 divided by 2, I end up with 4. In the fourth term, when I do 8 divided by 4, I end up with 2. So what I have is 8 times 2 plus 8x times 3 equals 4 times 5 plus 2x times 13. And that's a nice linear equation. So all of our steps from before are the same. We want to make sure we identify the restrictions. Let's go back and do that. So I look at the denominators, and I have three denominators. X equals 0, 2x equals 0, and 4 equals 0. This 4 never equals 0, so that doesn't do anything for us. X equals 0, check. We want to exclude that. 2x equals 0. If I divide both sides by 2, that's the same as saying x equals 0. So my exclusions are exclude x equals 0. So if I solve this equation and my only solution is that x equals 0, I'm going to say that it has no solutions. So what this tells us is we can't plug 0 into this equation. If we try, we'll get an error in our calculator because we're trying to divide by 0, and that's impossible. Okay, so let's continue. 8 times 2 makes 16. 8x times 3 makes 24x. 4 times 5 makes 20. And 2x times 13 makes 26x. Now we want x's on one side, numbers on the other side. So let's subtract 26x from both sides. On the right-hand side, the 26x's cancel. I have 24x minus 26x gives me 16 minus 2x equals 20. I want to move the numbers to the other side, so subtract 16 from both sides. Negative 2x is 20 minus 16 makes 4. Divide both sides by negative 2, and I get x equals negative 2. Now I'm checking, and this is not the value that I excluded, right? So my solution is x equals negative 2. So when you're doing your homework, just be careful because they might ask you to do excluded values in one step and solution in another step. So don't go straight to that solution. Make sure you do this which values to exclude first. Okay, let's do another example. So this one says 16 over 8x minus 8 plus 1 over 8 equals 2 over x minus 1. So let's start by finding the excluded values. So I have three denominators. 8x minus 8 is 0, 8 is 0, and x minus 1 is 0. Again, this 8 equals 0 never happens. In the x minus 1, if I add 1 to both sides, I get x equals 1. 8x minus 8, let's add 8 to both sides. Divide by 8, and I get x equals 1. So if you see that these two have the same excluded values, it might mean that they have something in common. So over here, I'm going to say exclude x equals 1. X equals 1 cannot be a solution. That's what I'm going to exclude. When I look at this equation, I'm going to write it a little bit differently because I notice that this 8x minus 8 has a common factor. So instead of writing 8x minus 8, I can write 8 times x minus 1. So this equation looks like 16 over 8 times x minus 1 plus 1 over 8 is 2 over x minus 1. And I do that because I don't want to put 8x minus 8 and x minus 1 into my denominator. So in my denominator, I'm going to use the 8, which I see appears here and here. And I'm going to use the x minus 1 because it appears in two places there and there. So I'm going to make my common denominator 8 times x minus 1. So let's multiply every term of the equation by that common denominator. Again, our equation has 3 terms, and I'm multiplying every term by that 8 times x minus 1. Okay, now I'm going to do some simplifying. What I see in the first term is that the 8 in the numerator and denominator cancel, and the x minus 1 in the numerator and denominator cancel. So I'm just left with a 16. In the second term, the 8 cancels, so I'm left with x minus 1 times 1. And in the third term, the x minus 1s cancel, and so I'm left with 8 times 2. So now we got to a place where we just have a linear equation. We're going to distribute, combine like terms, x's on one side, numbers on the other side. So I'm going to distribute this 1. Multiplying by 1 doesn't really change anything though, right? It just takes away your parentheses. And then 8 times 2 makes 16. Okay, on that left-hand side, I'm going to combine like terms because I have 16 and negative 1. So that gives me x plus 15 equals 16. I already have just one x, so I just need to move the 15. Subtract 15 from both sides, and I end up with x equals 1. Okay, so remember, an important step of solving rational equations is check your solution. And remember, we're checking to make sure that the value that we got as our answer was not the value that we said to exclude up here. And unfortunately, in this example, we say the solution is x equals 1, but up here we said exclude x equals 1. So since the only solution was an excluded value, this equation has no solutions. So we could just write no solutions. Sometimes we write it with curly braces with nothing inside it, or sometimes we write it with like a 0 with a line through it. So one important thing to remember is to check your solution at the very end. So go back to those steps, find what you're going to exclude, find a common denominator, multiply every term by the common denominator, solve the resulting equation, hopefully it's going to be linear, and then check your solutions.